My apologies in advance, this is my first time ever doing a video like this. Check the link in the description for a PDF copy of the Epicenter Location Practice Lab. If there isn't a PDF link, then just don't check it. Alright, so the first thing we need to remember is our discussion of triangulation. And if you recall, we need 3 seismic stations in order to locate the epicenter of an earthquake. And it just so happens they give us 3 of them. They give us a difference of an arrival times, and we are to calculate the distance to the epicenter for each one of these. So I have 2 tables, and I'm going to show you how to use both of these in order to find the distance. Okay, so our first city is Denver, Colorado, and it says that there's a difference of 2 minutes and 40 seconds. So I'm going to take this 2 minutes and 40 seconds, and we're going to use the easy graph, which is this one right here. And on the y-axis, it says difference in arrival time. Well, that's 2 minutes and 40 seconds. If you can see, each of these are split up into 3 categories. If you split a minute up into 3 sections, each one of those sections is going to be about 20 seconds. So if we have 2 minutes and 40 seconds, well, that's 2 of these little increments right here. So we're going to go up to the 2 and 2 over to get 2 minutes and 40 seconds. And then we're going to go over to our graph. Okay, and then we're going to drop down to find out that the distance to the epicenter is, well, let's see, this is 1, 2, 3, 4, 5. 5 increments is 1,000, so each of these increments is 200. So 1, 2, 3, so 3 times 200 gets us 600. So that's 1,600. And I'm going to note that right here. So the distance to the epicenter happens to be 1,600 kilometers. Okay. Now I'm going to do that for the other 2, and then I'm going to jump to this graph really quick. Houston, Texas, it says 1 minute and 50 seconds, so we're going to calculate that one. 1 minute 50 seconds would be, right here. Each of those is about 20 seconds, so 1 minute 20 seconds, 1 minute 40 seconds. So right between 40 and 60 is 50, so it's going to be right in between here. This is not an exact science. Well, actually it is, but not this part of it. Okay, and then we're going to go over and kind of drop straight down. Okay, so it looks to be just a little bit more than 1,000, and I think when I checked some sort of a key, it said 1,060. I mean, we can just go with it, but I'd accept 1,000. 1,060, or 1,100. Last one is going to be Chicago, Illinois, and we see that's 1 minute 10 seconds. So it's going to be right between, so this is 1 minute, this is 1 minute 20, so it's going to be right in between at 1 minute and 10 seconds. Go over to our graph and drop straight down. That actually looks to be somewhat around there. Okay, so each of those, like I said, was 200 kilometers. That's 2 for 600 kilometers, about, give or take. All right, now let's use the other graph really quickly. And what I have right here is a geometry tool called a compass. No, not the magnetic kind, but the geometric kind. Here's how it works. This point is a point of stability. This normally has some sort of a pencil, in this case just some lead in it, and we're going to use it to draw a circle around to find our epicenter. But in this case, what we're going to do is we're actually going to take this difference in arrival times, 2 minutes and 40 seconds, and we're going to go up here to our y-axis, and we're going to find 2 minutes and 40 seconds, which looks to be about, let's see, that's 2 minutes and that's 3 minutes. It's broken up into 3 intervals. Each interval would be 20 seconds, so it would be about here. See that little mark I made right there? Okay, you're going to take this compass and you are going to adjust it, so just kind of push this back and adjust this accordingly. So that it lines up with the 2 minutes and 40 seconds. So I'm going to try to do that as best as I can. Alright, so that looks to be what it is about. Oh no. Sorry about that. Alright, that is give or take 2 minutes and 40 seconds of length. So now we're going to go over to our little graph, and we're going to find the location where 2 minutes and 40 seconds is, where this distance is. So it's not here, it's not here. We're going to find, and it's about right there. So I'm going to very carefully mark that. Right? That is a very rough estimate, but if you drop down, I mean, you get, give or take, each of those is 5 intervals, so each of them is going to be 200 kilometers. That's about 1,200, 400. Hey, that's about 1,600, which is exactly what we got in our table. I'm not going to do that for the other two, but just so you know, that's how you would do it with a compass. I am going to give you a compass going into your competition. However, I don't think you need these graphs. All right, so we calculated the distance to the epicenter, and let's talk about what that actually means. So we don't really need these anymore. We just need our map of the United States. So, the distance to the epicenter of this seismic station says that it's 1,600 kilometers, which means I'm going to take this compass and I'm going to adjust it to get 1,600 kilometers of length right here. So you can see the scale. 1,600 would be right here. So that's 1,600 length. So we want to find it from Denver, Colorado. So we're going to go over to Denver, which is right here, and we're going to use this as a stable point. Now this is lead, and what we're going to do is we're going to draw a circle all the way around Denver. Cross that off as a New Year's resolution. I can use a compass. Oh, did I screw that up? Did I screw that up? Probably. No, looks fine. Right, so that's Denver. You can see my wonderful circle right there. If you can't, here's a zoomed version. Okay, the epicenter is anywhere along here. That is 1,600 kilometers in all possible directions from Denver. Now we just do that for the other three. So we have 1,060 kilometers, which should be much easier on our little friend. 1,060. Let's see, that's 1,000, that's 1,200, that's 1,100, so it's about 1,100. I'd say about 1,100. That is about 1,100. Okay, and that is for Houston, Texas. We're going to go over to Houston. Use this as a basis. And our circle's not going to go all the way into the paper, but that's okay. Alright, that's good enough. That's our second circle around Houston, Texas. The epicenter is 1,060 kilometers away from Houston in all directions. And now, as you can see, the circles touch in a few places, but we need that third circle to really pinpoint that exact location. So we go to Chicago, Illinois. Hey, Chicago, Illinois says that it is 600 kilometers to the epicenter. So we're going to find that. Oh, this is fun. Fun times. Building memories over here. All right. That's 600 kilometers, give or take something, probably. And we're going to go over to Chicago. An amazing city. Oh, no. Not amazing if you do that. Alright. Sometimes it might help to, like, rotate the paper instead. And we have our third circle. So I know it's hard to see, or it might be, but if you look at those three circles, oh, it's blurry. Hang on. I don't know what's wrong. Technical difficulties? There we go. There we go. All right. If you look at those three circles, they only all intersect kind of in one location. I say kind of because it's not perfect, but that's okay. We're not edging for perfection here. Looks to intersect somewhere around yonder. Kind of. Okay? that is all I wanted you to get out of this practice lab. These questions, you can do them if you want, but I really don't care. If you have any specific questions over these questions, feel free to leave a comment or just ask me whenever we come in on Friday. But that's basically the principle behind locating an epicenter. Remember, you need 3 seismic stations and just kind of know how to use a compass. So be kind of familiar with that. If you don't have one, either borrow one, or they're not too expensive at Walmart, I don't think. So yeah, that's how you calculate an epicenter, and I hope that was helpful.